Now, let us study another theorem. If two angles of a triangle are not congruent, then the side opposite to greater angle is greater. See the figure alongside. It is given that in triangle DEF, take angle E is greater than angle F. We have to prove that DF is greater than DE. Let us see the steps of the proof. We have three possibilities: either 1. DF is equal to DE, or 2. DF is less than DE, or 3. DF is greater than DE. Out of these three, only one is true. Case 1. Suppose DF is equal to DE. Therefore, according to converse of isosceles triangle theorem, angle E congruent to angle F. Let us mark it as statement 1. But it is also given that angle E greater than angle F. Let us mark it as statement 2. But statement 1 contradicts 2. Therefore, DF is equal to DE is not true. Therefore, any one of the remaining two may be true. Case 2. Let DF is less than DE, that is, angle E is less than angle F. Angle opposite to greater side is greater. But it is also given that angle E is greater than angle F. These two statements contradict each other. Therefore, DF less than DE is not true. Case 3. We have three possibilities. Out of these, we have proved from case 1, DF is equal to DE is not true. And from case 2, DF less than DE is not true. Therefore, this method of proof is known as proof by elimination. The third, DF greater than DE, must be true. Hence, in a triangle, side opposite to greater angle is greater. Coming to shortest segment theorem. Of all the segments that can be drawn to a given line from a point not lying on it, the perpendicular segment is the shortest segment. See the figure alongside. It is given that P is a point not on line L. Segment PM is perpendicular to line L. Q is any other point on L. Show PM is less than PQ. We have to prove that triangle PQM is right-angled triangle. Therefore, hypotenuse PQ is the longest side, that is, PM is less than PQ. Therefore, perpendicular segment is the shortest. The next theorem is, the sum of the lengths of any two sides of a triangle is greater than the length of third side. See the figure alongside. It is given that triangle ABC, we have to prove that 1. AB plus AC is greater than BC. 2. AB plus BC is greater than AC. 3. BC plus AC is greater than AB. Let us take point D on ray BA such that AC is equal to AD. We have to prove that according to the construction in triangle ACD, AC is equal to AD. Therefore, according to the isosceles triangle theorem, angle ACD is equal to angle ADC. Therefore, by adding angle ACB only on one side, angle ACD plus angle ACB is less than angle ADC. Since angle ADC is equal to angle BDC, that is, angle BCD is greater than angle BDC. Therefore, since side opposite to greater angle is greater, BD is greater than BC. Therefore, since BD is equal to BA plus AD, AB plus AD is greater than BC. Therefore, since AD is equal to AC, AB plus AC is greater than BC. Similarly, AB plus BC is greater than AC. BC plus AC is greater than AB can be proved. The sum of the lengths of any two sides of a triangle is greater than the length of third side. Let us solve some of the questions from exercise 3.4. Question 1. In triangle ABC, angle A is equal to 40 degree. Angle B is equal to 80 degree. Find the shortest and the longest side of triangle ABC. Solution. See the figure alongside. In triangle ABC, measure of angle A plus measure of angle B plus measure of angle C is equal to 180 degrees. Since sum of the measure of all angles of a triangle is 180 degrees, by substituting the given values, we get 40 degrees plus 80 degrees plus measure of angle C is equal to 180 degrees. 120 degrees plus measure of angle C is equal to 180 degrees. Measure of angle C is equal to 180 degrees minus 120 degrees. Measure of angle C is equal to 60 degrees. Therefore, measure of angle A is equal to 40 degrees, measure of angle B is equal to 80 degrees, measure of angle C is equal to 60 degrees. Therefore, measure of angle B is greater than measure of angle C is greater than measure of angle A. We know that side opposite to the greater angle is largest. So, in the given triangle ABC, side opposite to 80 degrees, which is side AC, will be the longest, and side opposite to the 40 degrees, which is side BC, is shortest. Thus, longest side is side AC and shortest side is side BC. Question 2. Angle ABD is equal to 30 degrees, angle ADC is equal to 70 degrees, and angle ACD is equal to 25 degrees. Arrange sides AB, AD and AC in descending order of their lengths. Solution. See the figure alongside. In triangle ABC, measure of angle B is equal to 30 degrees. Measure of angle C is equal to 25 degrees. Angle B is greater than angle C. Therefore, AC is greater than AB. Since side AC is side opposite to greater angle, let us mark it as statement 1. Measure of angle ADB plus measure of angle ADC is equal to 180 degrees, since they are angles forming a linear pair. Substituting the given value, we get measure of angle ADB plus 70 degrees is equal to 180 degrees. Measure of angle ADB is equal to 180 degrees minus 70 degrees. Therefore, measure of angle ADB is equal to 110 degrees. In triangle ABD, measure of angle B is equal to 30 degrees. Measure of angle D is equal to 110 degrees. Therefore, measure of angle D is greater than measure of angle B. Therefore, side AB is greater than side AD, since it is the side opposite to the greater angle. Let us mark it as statement 2. Therefore, from statements 1 and 2, we have AC is greater than AB is greater than AD. Question 3. In triangle ABC, sides AB and BC are congruent. 1. If A-P-C, then show that BP is smaller than congruent sides. 2. if A-C-P, then show that BP is greater than congruent sides. See the figure alongside. It is given that in triangle ABC, side AB is congruent to side BC. Point P is in between A and C. We have to prove that BP is less than AB. BP is less than BC. Let us see the steps of the proof. 1. If A-P-C, then show that BP is smaller than congruent sides. In triangle ABC, it is given that side AB is congruent to side BC. Angle BAC is congruent to angle BCA by isosceles triangle theorem. Therefore, angle BAP is congruent to angle BCP, since point P is in between A and C. Let us mark it as statement 1. In triangle BPC, angle BCP is less than angle BPA by exterior angle theorem. Therefore, angle BAP is less than angle BPA from statement 1. Therefore, side BP is less than side AB. Let us mark it as statement 2. In triangle BPA, angle BAP is less than angle BPC by exterior angle theorem. Therefore, angle BCP is less than angle BPC from statement 1. Therefore, side BP is less than side BC. Let us mark it as statement 3. Therefore, from statements 2 and 3, we have BP is less than the congruent sides. 2. Similarly, we can show that if C is in between A and P, then BP is greater than congruent sides. Question 4. In triangle PQR, PQ is equal to 4 cm and QR is equal to 6 cm. What can be the length of the third side PR? Find the minimum and maximum possible lengths of side PR. See the figure alongside. In triangle PQR, it is given that PQ is equal to 4 cm, QR is equal to 6 cm. We know that sum of any two sides of a triangle is always greater than the third side. Applying this property for given triangle PQR, we get PQ plus QR is greater than PR. Substituting the given values, we get 4 plus 6 is greater than PR. Therefore, 10 is greater than PR. Let us consider it as equation 1. Also, PQ plus PR is greater than QR. Substituting the given values, we get 4 plus PR is greater than 6. Therefore, PR is greater than 6 minus 4. Therefore, PR is greater than 2. Let us consider it as equation 2. Combining statements 1 and 2, we get the range for the third side PR as 10 is greater than the third side PR is greater than 2. That is, 2 is less than the third side PR is less than 10.